I'm very sure you will be finding this way, this dipole moment, and like you will be crystal clear about the questions, how to find polar and non-polar. So in dipole moment, there are three type of questions which comes from this topic. One is which of the following compound are polar, which of the following are non-polar. This is one question. Second question is compare the polarity. Suppose if two or more compounds are polar, like water is polar, ammonia is polar, HF is polar, HCl is polar, which is more polar? This is a question. Third category, find the exact value of polarity. Like there is a formula which is percentage ionic character. So they can ask which like how much ionic character exists in this particular bond or in this particular compound. So because we know no bond is 100% covalent, no bond is 100% ionic. So calculation like what percentage of ionic character is there in the compound, that also we can find. So these three category of questions are there from the topic dipole moment. Okay. So first we should know what is dipole moment. So dipole moment is denoted by mu. It is denoted by mu. So mu is equals to Q into D. This is a formula of dipole moment. Now what is dipole here? What is dipole? Dipole is dipole, two poles. And in chemistry, the poles are of opposite charges. In physics also. In physics also, we listen this word many times, dipole. So when two charges like positive and negative, they are separated by some distance d, then some, like this is dipole. When positive and negative charges are there, this is dipole. When they are separated by d distance, then the value, the numerical value which we calculate is known as the dipole moment. And there are two things. One is the magnitude of the charge, like how much charge is there. Positive and negative charges are there. But suppose in chemistry, like the charge can be partial also here, because HF bond is there. There is not complete positive charge on hydrogen, but there is partial positive. Similarly, on fluorine, there is partial negative. So partial charges are there, but this charge can be different in different compounds. So that is why we are taking the magnitude of the charge and the distance between the charges. So this value, what is coming from here, is known as the dipole moment. And this dipole moment is a vector quantity. It is a vector quantity. It is a vector quantity. Vector quantity means it depends on the direction, right? It depends on the direction. It is not a scalar quantity. It depends on the direction. Like what is the direction of the dipole moment? It is from positive to negative. From positive to negative, we decide the direction. So this will be the arrow. How to remember this? At the end of arrow, there is a positive charge. So positive to negative, right? At the tail of the arrow, we are having a positive charge. So positive to negative. This is the dipole moment direction. Okay. So this distance, this we can never find out. We can never find out this distance because it is always a experimental data. So this will be given in the question. This d value will be given in the question if they want to calculate the value. And this charge, what is the value of charge? Charge value is like when one electron, suppose complete positive and complete negative charges are there, then it is 1.6 into 10 raised to power minus 19 coulomb, because it is the charge of electron. So when there is one negative charge, it is 1.6 into 10 raised to power minus 19. When there is one positive charge, the same charge value will same, just the sign is opposite. And we have taken the mode value. That means we are nothing, we are not even thinking about the magnitude plus minus. Just the value, just the numerical value of the charge is required, which is 1.6 into 10 raised to power minus 19. And it is the value when complete positive and complete negative charge is there. Okay, so this is the one thing. And now there is a formula. Suppose we are having this is this as a dipole and this as a, or we can say vector. The resultant vector, everyone knows in physics, we see this resultant vector will be in between them. And of course it will be coming from the angle also, like whatever the angle is there. So there comes a formula. Net dipole moment is equals to under root mu1 square plus mu2 square plus 2 mu1 mu2 cos theta. Right? We are very familiar with this formula. So when suppose let us take, if theta is, let us take 0 degree. If 0 degree, that means two dipoles are just one over another, and they will add up here. They will add up. And by the formula also we can find out mu net. This is the first thing. Mu net is equals to mu1 square plus mu2 square. And one more thing, mu1 is equals to mu2. Like this is also the condition we are taking. Mu1 is equals to mu2. Otherwise, like there will be two values, two different values, mu1, mu2. So we are taking mu1 is equals to mu2, then mu1 square plus mu1 square plus 2 cos 0 is 1. So 2 mu1 square. So which is coming as 4 mu1 square, and 4 under root is 2. So this is coming as 2 mu1. Right. So this is the net dipole moment value. Fine. We got it here. And then second, suppose if theta is 180 degree. Theta is 180 degree. Cos 180 is minus 1. Cos 180 is minus 1. So then in that case, again mu1 square is equals to mu2 square. So mu1 square plus mu1 square minus 2 mu1 square, because cos 180 is minus 1. So minus is coming there. So this is coming at 0. So mu net is 0. So the thing is, we are calculating this thing, but like we should understand the significance also. Because when the two dipoles are equal and opposite, then of course they will cancel each other. They will cancel each other. So overall dipole moment will be 0. Right? Yes, Vedant.
Sir, I understood dipole moment is net charge into the distance between the positive and negative charge. But like, what does dipole moment actually mean? Like, is it some kind of quantity or attraction or something like that?
No, no, it is not a attraction. Like when two charges are separated, so some dipole is generated. Like some two charges are separated by a d distance. Suppose, for example, we are having, yeah, this is a this is a numerical value by which we can find the polarity. For example, HF bond is there, right? HF bond is a polar, but we do not know what amount of polarity it carries in this molecule. So to calculate the percentage polarity in the compound, we define as dipole moment. So for a bond, if a bond is polar, so there is some partial positive and partial negative charge, right? For HCl also, this is having longer distance, so that is also polar, partial positive and partial negative charge. Now both are polar, but what amount of polarity they carries? So to find that amount of polarity, we define a term which is known as dipole moment. Okay, so this will be having mu, this will be having mu. Both mu will be different. The one which is more polar will be having more value of mu. And how we can define that? Like more is the distance, more the polarity is, more are the charges, more the polarity is. Okay.
Yes, sir. So, but I have one more question.
Hmm.
Like, why does polarity depend on dipole moment? Like, is it just defined like that, or is there some logic?
Why does?
Polarity depend on dipole moment.
No,
Is
no,
there some
polarity is, polarity is not depending on dipole moment. To calculate the polarity, we are defining a term which is known as dipole moment.
okay.
If theta is equals to 90 degree, what is the value of cos 90, Varun?
That one.
Zero
Cos 90, Varun,
cos 90?
Zero.
0, 0 yaar. 2 mu1 square into 0. So that is coming as mu1 square plus mu1 square, 2 mu1 square. So we can say mu1 under root 2. Like this is the simple thing we can see. So sir, why you are taking the physics? Because it will be required when we'll be finding the comparison of polarity, when we'll be doing this thing will be required. Okay. So now we have to see first type of question. First type of question to find which of the given compound are polar or non-polar.
Sir, I have one doubt.
Yes.
So in that graph which you plotted, what does x-axis represent and what does y-axis represent?
Okay. Yeah, fine. So this is a mu1 vector, this is a mu2 vector, and this is mu net. Right? This is not a graph actually. It is just a vector addition of two vectors. Right? Two vectors are there. We are finding the net value. We are finding the net dipole moment, or we can say net vector quantity. And that is given by a formula. Right? And it depends what is the angle between two vectors. By that, we can find the net dipole moment or net vector. In physics, you haven't seen this, Varun?
The vectors I've seen, but I didn't know what here.
But now you got it?
Yes, I got it.
Okay. Very good. You should ask the question, like whatever the doubt is, you should ask it. Fine. Yes. You give me answer of this question. Suppose we are having BF3. Or let us take the example CO2. CO2 example we are taking. So structure we have to draw for CO2, that will be this one. And the exact structure, we cannot make CO2 in any different way because CO2 exists linear. So we have to make it linear only. And then there will be a partial positive charge, partial negative charge, partial negative charge. Then we have to draw the direction of dipole moment, which is from positive to negative. And there are two dipoles and they are equal. And the angle is 180-degree, right? So net dipole moment will be zero. Net dipole moment will be zero, right? Because both the dipoles are equal and opposite. That's why net dipole moment is zero. So this compound is polar or non-polar? If net dipole moment is zero, so it is non-polar. There is no polarity in this compound. It is non-polar, right? Let us take one another example, BF3. So BF3 boron is sp2 hybridized and it is having trigonal planar geometry, right? And BF fluorine is more electronegative, so dipole moment direction will be from positive to negative. Positive will be on boron and negative will be on fluorine. So positive to negative from boron to fluorine, we are having the dipole moment direction. Fine. This is the direction of dipole moment we are having. And then, like if you want to find, if you want to ask me, sir, what is the value of net dipole moment? So we can see the angle between these two vectors is 120-degree, right? And when it is 120-degree, let us see when it is 120-degree, let us see this case also. If theta is 120-degree, what is the value of 1 cos 120, Afik?
So 1/2.
1/2, yes. Plus 2 mu1 square 1/2. So this will get cancelled.
The cos 120 is minus half.
Minus half. It is minus half. It is minus half here. So this will get cancelled. Mu net will be coming as mu1 only. So what is this? When two dipoles are there and the angle is 120-degree, then the net dipole moment which will be coming in between them, that will be having same value as any of the dipole, right? Because both the dipoles are equal. So net dipole moment will be mu1 only, right? So that's the result. So suppose when the if we want to find out the net dipole moment of two BF bond, so net dipole moment will be coming in between them exactly, and this will be just equal to one BF bond, right? One BF bond. And now we can see resulted dipole moment from these two bond is this one, and one bond is just exactly opposite to this. So we can see two dipoles are there which are equal and opposite. So that is why net dipole moment will be zero now. Net dipole moment will be zero. They both will get cancelled. So again, the compound is non-polar here. Again, the compound is non-polar. Have you understood this question? Everyone? Yes. Okay. Third example. We want to take PCl5. PCl5.
So we will have to remember the structures, not structures, the angles between, if it's
Like
trigonometric.
this is the thing which we have done now. This is not
So
in
there are some with like 2 degrees 9 minutes, like that is also there, right?
what 2 degree?
There are some degrees in decimal also, right? In the
Arre nahi yaar. Please see. I'll be clearing you everything. Right. 109.5 degree angle is there for tetrahedral. I'll be clearing you that thing. Don't worry about that. Okay. You won't be having any doubt. Okay. So if we want to see this thing, PCl5. When PCl5 molecule is there, so we can see this is a trigonal planar geometry, and we are having this bond and this bond, and they are equal and opposite. So at least we can say there is not net dipole moment is coming from above and below because they are cancelling each other. And now, like the geometry which is existing in the plane, like we know it is trigonal planar, three bond in one plane, one bond above, one bond below. So that above and below they are cancelling each other, but the bond which are in the plane, they are having angle 120 degree, right? They are having angle 120 degree. Now that will also get cancelled. This one and this one, it will also get cancelled, right? So net resultant dipole moment will be zero here also, right? Got it? Because this one and this one got cancelled, and these three are there in the plane, and they are at 120 degree. So it is just like BF3 now. Here also net dipole moment is zero. So PCl5 molecule is also non-planar. Let us see fourth example also. SF6. SF6. Sulfur is there. It is octahedral, right? We know it. It is octahedral. This is octahedral, right? There are 90-degree angles, 180-degree angles. And now we can see here, you can see this geometry. Two bonds which are equal, they are equal and opposite. You can see this one and this one, they are equal and opposite, again equal and opposite, again equal and opposite. So yes, here also resultant dipole moment is coming at zero. So now, like whenever we are seeing these cases, so there comes a result comes in my mind. What is that result? Actually, the compounds or the geometry which are regular geometry, they will be non-polar always. Regular geometry will always be non-planar. We do not need to even check. And how to find which are regular geometries? We have seen this. When central atom is having all the side atoms same and there is no lone pair on the central atom, those geometries are considered as regular geometries. And there will be net dipole moment will be zero. I'm repeating it again. Like from these observations, even we take IF7, we can take IF7, we can take CH4. All these cases, net dipole moment is zero. So what is the observation coming? When central atom is having no lone pair and all the surrounding atoms are same, that means regular geometry. In that case, net dipole moment will be zero. And we have seen this, Vibhani, Varun, Afik, like the bond angle. If you remember, we have compared bond angle. Those were having equal bond angles. For example, BF3, BCl3, they are not having different angles. They both are having 120-degree angles. What was the reason? Regular geometry. No lone pair, all the surrounding atoms are same. So no net repulsions. So no change in the bond angle. That is why we can say no change in the polarity. The compounds will be non-polar. Because the geometry exists in most symmetrical way, right? So they are having no polarity. So this is the result, what I can write it here. Regular geometries. Regular geometries. Regular geometry means central atom having no lone pair and all surrounding atom are same. Then those all cases, then in those all cases, net dipole moment is zero or geometries are non-polar. So, by this particular line or definition, we have done so many cases. So many cases are done. We won't be finding like this. Vedant was asking, sir, we need to know the angle. No. Like by this definition alone, by this definition only, we can solve many questions. Now, but sir, there can be lone pair. Of course, there can be lone pair. So when the lone pair will be coming, so let us see what is the behavior of the dipole when the lone pair comes on an atom. So this is a lone pair. So lone pair is again an electron cloud only. Lone pair is a pair of electron. So the dipole moment direction will always be in the direction of lone pair. Dipole moment direction will always be in the direction of lone pair. Like if the lone pair is above, dipole moment is above. Lone pair is below, dipole moment is below. Why? Because dipole moment direction is from positive to negative, and lone pair is a pair of electron, and atom is a nucleus here, right? So nucleus to electron only, right? So we can say dipole moment direction, dipole moment direction for lone pair is always in the direction of lone pair only. One very interesting point I'm telling you now, very important, and you will be impressed by this line. What is that? When one lone pair is there on central atom, when only one lone pair, those compound can never be non-polar, because dipole moment of lone pair can be cancelled by lone pair only, because it cannot be cancelled by any other dipole. Suppose a dipole is there, and if the dipole is there in the opposite direction, so that dipole must be same not to cancel. So if there is only one lone pair, then the dipole of lone pair cannot be cancelled. It can be minimized. Like one dipole is there, one dipole is there in the opposite direction. If this is mu1, this is mu2. They can subtract each other, but they cannot cancel if mu1 is not equal to mu2. So if central atom is having only one lone pair, then in that case, net dipole moment can never be zero. So those all compound will always be polar. So this is the another case which we have covered. If central atom is having only one lone pair, then net dipole moment, then net dipole moment mu r is non-zero always, or the geometry is polar, right? If the net dipole moment is not equal to zero, that means the molecule is polar. Let us take the example here. Example we can take, many examples we can take. I am taking one only, NS3. So first we have to, like this we have to know, yeah, this we should know if it is having lone pair or not. We have done this. First we will be finding the hybridization. What is the hybridization here? 5 is the valence electron of the nitrogen. 5 plus 3, 8. 8 divided by 2, 4. 4 means sp3. And there are 3 side atoms. So Vedant, this is the another way to find the lone pair and bond pair. If the hybridization is sp3, are you able to find the hybridization, Vedant?
No, sir, I don't know how to find it.
Afik, Vibhani and Varun?
Yes, sir.
Yes, sir.
Okay, so Vedant, you can see there is a very simple way to find the hybridization. What you have to do, you have to find the steric number. And for steric number, valence electron plus hydrogen or halogen plus minus charge divide by 2. Divide by 2, right? This is the formula to find the steric number. Valence electron of central atom plus how many hydrogen and halogens are there, plus minus charge. If there is negative charge, you can add. If there is positive charge, you can subtract. Because positive means less, right? So we have to subtract. If negative charge is there, we have to add. So NS3 is there, for example. So what are the valence electron of the nitrogen? 5. This we know. 5 are the valence electron. There are 3 hydrogen. So 5 plus 3, there is no charge, divided by 2, 4. 4 means 4 orbital. The orbital will start from S. So S and then 3p. So sp3, right? So we have to make the sum as 4 of the orbital, so which is coming as sp3. If the asterisk number is coming as 5, sp3d. If it is coming as 6, sp3d2. If it is coming as 2, sp2, then sp. If it is coming as 3, then the hybridization will be sp2. Okay. And bond pair and lone pair also we can find out in a very simple way. Because steric number is coming as 4, that means sum of lone pair and sigma bond is coming as 4. So there are 3 side atoms only. That means 3 sigma bond. So 1 lone pair is there. So we can say this compound is polar. This compound is polar. Let us see one more example. If we are having SO2, you tell me, is this polar or not? SO2, everyone. Just find the hybridization and then see it is polar or not. Yes, polar or not? Afik,
So polar.
Vivani,
Polar.
Varun,
Polar.
Vedant.
Sir, I'm not sure.
So how to find the hybridization? First, we have to find the hybridization. How to find?
SP2.
Yes, that is sp2. And if sp2 it is, that means there should be 3, like lone pair plus sigma bond, sum should be 3. There are 2 side atoms. That means sigma bond can be 2 only, na? It won't be 3. Like
Okay.
sigma bond between 2 atoms is always 1. So there are 2 side atoms. So the number of sigma bond is 2. So 1 lone pair is there. 1 lone pair is there. That means it is again polar. Okay. So this is the case when 1 lone pair is there. Now the third case we are taking. What is the third case? Third case is, suppose there are 2 lone pairs now. Lone pair are 2. Now there can be again 2 cases here. 2 lone pair are there on central atom. Then beta, you can see when the lone pairs are opposite, like lone pairs are opposite like that. So now the dipole moment can be 0. I'm not saying that it must be 0, but can be 0. Because the lone pair dipole will cancel each other, and other bonds which are there in the compound, if they are also cancelling, then the net dipole moment is 0. But suppose lone pair are not at 180, not at 180, then that can never be 0. That we can say. If the lone pair are not at 180, then the dipole moment of lone pair is not going to be cancelled anyways, right? Then resultant dipole moment is not 0. It must be polar. This one can be non-polar. It can be non-polar because dipoles of lone pair are cancelling each other. I am taking both the cases. Let us see XCF4. XCF4. So what is the hybridization of xenon? Xenon is having how many valence electron here? 8, right? 8. How many fluorine, hydrogen or halogen we have to count? So 4 divided by 2, which is coming at 6. 6 means sp3d2, right? sp3d2 it is coming. So sum should be 6, but there are only 4 side atoms. So there are 2 lone pair. 2 lone pairs are there. So this will be a xenon at the central atom. And there are 2 lone pairs. And if you see, this geometry is square bipyramidal. If you remember everyone, this geometry is square bipyramidal, which is this.
Can you tell me how to find the number of lone pairs from hybridization?
No, from hybridization we cannot tell. Like 6, it is the sum is 6 now. So there are 4 side atoms only. So
Okay.
6 minus 4, 2. There are 2 lone pairs,
Okay, sir.
right?
So steric number is like the number of
Sigma bond plus lone pair.
sigma bonds.
Yes. And sigma
Okay.
bond is equal to number of surrounding atom.
Okay, sir.
So one lone pair is there, and the second lone pair we will be putting at this position. So they are equal and opposite, right? And the geometry is square planar. Geometry is square planar. So XCF4 will be having square planar geometry. One fluorine, another fluorine. Or we can take all the fluorines here. Do you remember the geometry are here? This was square planar. One lone pair, one lone pair. Now you can see the lone pairs are cancelling their dipoles and the bond pairs are also cancelling the dipoles. So we have to make the geometry, then we will be able to decide. So yes, in this case, net dipole moment is 0 and the compound is non-polar. This is non-polar. Fine. Okay. Now let us see for this one. It will always be polar. Just see the example. Just see the example. What is the example we are taking? Let us take the example as H2O, water. So when water is there, what is the hybridization? How many valence electron of oxygen, Vedant? 6. There are 2 hydrogen divided by 2, which is 4. So hybridization is coming as sp3 here. So total sum is 4, but there are 2 side atoms only. So 2 bond pair, 2 lone pair. Like 2 sigma bond, 2 lone pair. So
Yes.
and sp3 means tetrahedral. So when we'll be putting 2 lone pair in the tetrahedral geometry, the geometry overall becoming as bent. So you can see the lone pairs are not cancelling their dipoles. So this compound is polar. Net resultant dipole moment is not equal to 0. This is polar. So now we actually know why the water is polar, right? Because the overall dipole moment, it is not the bond. Like sometimes students make a mistake. They see in water because of OH bond it is polar. So it should be in the XCF4 also. In XCF4, XCF bond is polar. But it is about the bond. If you find the polarity of the molecule, then you have to calculate the vector addition, net vector, which is cancelling each other. So which is coming at 0. So bond polarity is there. That doesn't mean the compound is also polar, right? If the bond is polar, compound can be polar, compound can be non-polar. It will depend on the overall vector addition of the dipoles, right? In the molecule. So have you understood all these 3 cases?
So
Everyone?
in the last case, between oxygen and the lone pair, which direction will the dipole moment be?
No, that we cannot tell. That we cannot tell because we do not know what will be the actual value of the net dipole moment, right? Because we do not know the distances between the dipoles. We do not know the distance of oxygen and lone pair, hydrogen and oxygen. We do not know the magnitude of the charge. So we cannot tell in what direction the net dipole moment will be. And they will not be asking this. Never. No one can tell, right? But have you understood these 3 cases, everyone? Can we do one question now?
Yes.
Okay, first you do this one. So from these 3 cases, you can solve this, right? If there is a geometry which is non-regular, then you can make that and then you can see the dipoles are cancelling or not, right? If there is one lone pair only on the central atom, it must be polar. Okay, done.
So 1 second. So 1 minute.
JEE Mains 2025 is going on, and today was the first day. I will share you the questions which has came from like the topics which we have done.
So how is the paper?
The paper I haven't seen because it was on today only. So whenever I get a PDF, it is from memory based only. Paper will be released by NTA later, but some memory based PDFs are coming, and they are also authentic. I'll see it. Like the questions are coming more from organic. There are 12 questions from organic among 30 questions.
So now it's 25, right?
It's 25, yes. So among 25, it's 12 from organic only.
Sir, how many sets were there?
2 sets. 1 day, 2
Okay.
sets, and there are total 5 days. So total 10 sets are there in one session of JEE.
So in today's one set, only 12 questions came from organic.
One set. One set means in the morning session, there are 12 questions from organic chemistry. Like it generally happens like this only. Most of the like more questions are from organic, around 10 questions. And from physical, it is least physical chemistry.
Physical, like this chemical equilibrium and all that.
Yes.
So thermodynamics is also physical.
Thermodynamics is also
Is it physical chemistry or inorganic?
like wherever we are having numerical portion,
Hmm.
it is coming from the physical chemistry, mole concept, atomic structure, redox, chemical equilibrium, ideal gas, real gas, thermodynamics.
Okay, sir.
So now let us discuss this. Vivani, have you done?
Yes, sir.
Varun,
You're doing so. Almost.
Afik,
So doing so.
Sir, in advanced also physical chemistry least amount of questions will come.
in advance, the course like we can say the questions are more from organic, but generally it is equal weightage.
Okay.
Done so.
But organic is most important one, organic and inorganic. If you do handle these two better, then overall your paper will be good, right? So you more focus on organic and inorganic because it will take lesser time to solve. And
Yes, sir.
and most of the question you will be able to solve in the organic and inorganic. In physical chemistry, you have to find the exact value of in the numerical question,
Yes, sir.
and that like in there the chances of mistakes are more.
Yes, sir.
Okay, so NO2 minus, NO3 minus. Let us discuss it now. What is your answer coming, Afik? Polar compounds.
So non-polar.
Polar, I asked polar, but you can see you have found non-polar.
So I made a mistake, yeah. Search polar.
Vibhani?
Polar.
No, no. What is the answer coming?
Oh, total number of
Okay, you have done for every case. Like it is polar, it is non-polar, like that.
yes, sir.
Okay. Varun?
So first one is polar, second one is non-polar.
Okay, wait, Varun. First one is polar. I'm writing P. Polar. Second one is
Non-polar.
okay.
So
Third,
then non-polar.
non-polar. Fourth,
Non-polar.
So I'm not sure. So
Vibhani, what do you say? Fourth,
Non-polar.
non-polar. Fifth one,
non-polar.
So polar.
fifth one is polar. Sixth one,
So polar.
polar. Seventh, Polar. Eighth,
So polar, non-polar.
non-polar. Ninth,
Sir, polar.
non-polar. 10th,
So polar.
non.
Not plus, non-polar.
11th,
Polar, sir.
polar. 12th,
So polar.
13th,
So, non-polar.
non-polar. 14th, polar. 15th, anyone can answer. 15th,
Polar.
polar. Yes. So who got all correct? Anyone? Okay, let us discuss it now. So in the NO2 minus, the case is very clear. It is having the hybridization H 5 plus 1 6. There is oxygen, like we have to see hydrogen and halogens only. So 5 plus 1 6 divided by 2 3. There are two side atoms, means one lone pair. So yes, it is polar. sp2 one lone pair. This is the case of the one lone pair. NO3 minus, you can see every side atom is same Vedant, and the hybridization is coming as sp2. So if it is sp2, there are three side atoms. That means there is no lone pair. So it is the case of regular geometry. And regular geometries are non-polar.
Yes.
SO42 minus, again 6 plus 2 8, 8 divided by 2 4. 4 means sp3, side atom are 4 and they are same. So again regular geometry, again non-polar. PCl3F2. So PCl3F2 we have to make, and we know more electronegative atom will be coming on the axial position here. So here again you can see net dipole moment is 0 only. And if we want to talk about PF3Cl2, so PF3Cl2 will be like this. PF3Cl2 is like this. So like dipole from the above is cancelling, but dipole moment in the plane is not cancelled. They are opposite, but they are not equal. So net dipole moment is not equal to 0. It is polar. SO2Cl2. What about SO2Cl2? First, you see what is the hybridization of sulfur. That is coming as 6 plus 2 8 divided by 2 4. 4 means sp3. There are four side atoms. Four side atoms means there is no lone pair.
Yes.
It is not a regular geometry also. So we have to make it. We have to draw it. So, but it is tetrahedral. Like sp3, four side atoms. So it is tetrahedral. So when it is tetrahedral, so it cannot be zero. Yaar. It cannot be zero. Because suppose the dipoles are like you might think, sir, why you draw it like that? You can draw it like that also, sir. You can draw it like that also. Now it will be non-polar, sir. You can see it is tetrahedral and bond are just equal and opposite. So it will be non-polar. But the thing is, it is not a planar geometry, right? This is tetrahedral. Bond angle is 109 degree 28 minute. It is not a planar geometry. The bonds are not exactly opposite to each other. Like they are equal. They are opposite. But the theta is not 180 degree. So they will not cancel each other. Right. So net dipole moment is not coming at 0 here. So it is again polar. Same thing is in CH2F2. This one is again tetrahedral. Carbon, hydrogen, hydrogen, fluorine, fluorine. Again, the net dipole moment is not 0. It is polar. CF4, it is regular geometry. How? We can say 4 plus 4, 8. 8 divided by 2, 4. 4 means sp3. All the side atoms are same. There is no lone pair. So it is regular geometry. It is non-polar. BF4 minus also regular geometry. XCF2. XCF2 is 8 plus 2, 10. Hello? Huh? Yes, XCF2. If we talk about XCF2, then central atom there will be xenon, and fluorine is okay. Let us see the geometry first. Xenon is coming as sp3d because it is 5 plus, sorry, 8 plus 2, 10 divided by 2, 5. 5 means sp3d, and 2 side atoms are there, that means 3 lone pair are there. So 3 lone pair, we are putting it on the equatorial position. Okay, this we have done here. In the trigonal bipyramidal geometry, more electronegative will be on the axial, less electronegative will be on the equatorial, right? And now we can see all the dipoles are equal and opposite, so it will be cancelling, and the lone pair will be cancelling each other, right? So this will be non-polar. IF3, what about IF3? Let us find the hybridization here. So this is 7 plus 3, 10 divided by 2, 5. 5 means sp3d. There are 3 side atoms, means there are 2 lone pair. So IF3 shape will be I, F, F, F. There are 2 lone pairs, right? So we can see here, everyone can see that that dipole moment will not be equal to 0 because they are not opposite. They are not equal dipoles. So yes, it will be polar. BRF5, 7 plus 5. 7 is the valence electron of bromine plus 5 halogen. 12 divided by 2, 6. 6 means again sp3d2. This is sp3d2. So if it is sp3d2, that means we can say 6 should be the steric number. There are 5 atoms, side atom means 1 lone pair. So it is polar. IF7, 7 plus 7, 14. 14 divided by 2, 7. So steric number is 7. There are 7 side atoms, means 7 sigma bond. There is 0 lone pair. All the side atoms are same, regular geometry, non-polar. NO2Cl. What is the hybridization of nitrogen? 5 plus 1, 6 divided by 2, 3. 3 means sp2. So it is sp2 hybridized. So if we want to find NO2Cl, nitrogen will be the central atom here, right? And there are 2 oxygen and 1 chlorine. So with chlorine, there will be 1 bond formed, and with oxygen there will be double bond, and with 1 oxygen there will be a coordinate. So here also we can see that dipoles are not opposite, or we can say not equal. Like this dipole moment will be coming this one, and this will be this one, but they are not opposite, right? So it will not get cancelled. So it is again polar. NF3, case of 1 lone pair, just like NH3, so it will be polar, right? Have you understood this one, this question complete?
Yes, sir.
Vedant, you also understood?
Yes, sir.
Very good. So I'm giving one more question also now, right? I'll be giving only 4 compounds. You have to find out will it be polar or not.
Okay, sir.
Varun, you got it?
Yes, sir, got it.
Very good, yeah. Vibhani,
Yes, sir.
Afik,
Yes, sir.
I'm adding one more thing now in the question. Like the question is asked combinedly. They will include polarity also. Sorry, not polarity, planarity. Like which of the following compounds are polar and planar? And we can say polar and non-planar. Like anything can be added. So polarity we know how to find. Planarity, what is planarity? If all the atoms are in one plane in a molecule, that means the compound is planar. And one thing that I have told you many times, whenever there are 3 atoms only, they will always be in one plane, because 3 atoms can make plane. Anywhere if they are put, they will be joining and they will be making one plane. So whenever 3 atoms are there, suppose in this case, we do not need to check here. It will always be planar, right? It will always be planar. So whenever there are 3 atoms, it will always be planar. For more than 3 atoms, we have to check. Like square planar, it is planar geometry. Linear, it is planar geometry. Trigonal planar, it is planar. Tetrahedral, non-planar. Pyramidal, non-planar. T-shape, it is planar. T-shape is planar, right? T is planar. T is in one plane here. Like, you understand, this is a T-shape and this is coming in one plane. Seesaw, non-planar. Square pyramidal, there is a square, one bond above. So yes, it is non-planar, right? So that parallelly we have to check, and we can easily check because we by the for finding the polarity we have to check the geometry, and geometry itself will be telling that it is planar or non-planar, right? So I'm giving you a question here. Which of the following are non-planar and polar. Okay, non-planar and polar. That's the question. Okay, so let us do it. NH4 plus SO2 BeF2 SO2 SOCl2 SOCl2 SO3 H2O NS3 PF3Cl2 SF4 I3 minus. Yes. Do up to here. Integer type of question it is. So what is the value coming?
We're done, sir.
Done?
Yes, sir.
Afik,
So 1 minute, sir.
Vibhani,
Doing, sir.
Vedant, what is your answer coming? Like total net answer.
4.
This weekend, this Sunday, we are having the test, and the question will be from acidic and basic strength. I'll be giving you subtopics: acidic and basic strength, aromaticity, chemical bonding, complete. Okay, done.
Yes, sir.
NH4 plus. What is your answer coming, Afik?
So like it's not part of it. Like,
It's not part of it.
like it's not so polar.
No, no, I'm asking what is the net answer? Non
Net 5, sir.
5. Vibhani,
3.
3. Varun,
So 5.
and Vedant, your answer is 4.
Yes, sir.
Okay, let us see. First compound is non-polar. Yes, correct. And it is, but planarity I cannot write P because otherwise it will be confusing between.
Okay.
So I will be writing it complete, non-polar and non-planar also. SO2, SO2 is polar because one lone pair wala case, and then it is planar also because 3 atoms are there. So again, this is not our answer. Polar it is, but it is not non-planar. BF2, BF2 is non-polar, but it is planar. This is not our answer. SOCl2 is polar. It is again a case of one lone pair, and it is non-planar. Yes. Why it is non-planar? Because that is pyramidal. The hybridization, if you find, it is coming as sp3 and there is one lone pair. So sp3 and one lone pair, it is pyramidal, right? So pyramidal geometries are non-planar. So this is our answer. SO3, SO3 is non-polar. Non-polarities, right? All the atoms are in one plane because it is trigonal planar and it is planar, right? So it is again not our answer. H2O, H2O is planar. So like if it is planar, it is not our answer. It is polar. NS3 is pyramidal, yes. So yes, it is polar. Yes, it is non-planar also. So correct, it is our answer. PF2, PF3Cl2. PF3Cl2 is polar here. We have seen it. And it is non-planar also because it is trigonal bipyramidal. All the atoms can never be in one plane. So this is again our answer. SF4, SF4 will be polar because it is a case of one lone pair. And then it is seesaw shape. Seesaw can never be in planar. So it is non-planar also. So this is again our answer. I3 minus is planar. And it is non-polar because the dipoles are equal and opposite. It is linear, right? This is linear. This is linear. We have seen it. So the dipole will be cancelling each other. So non-polar and planar, right? So this is again not the answer. So 4 is the right answer. So Vedant, you got these 4 only?
Yes, sir.
Correct. Afik, which one you considered extra?
So BA or BEF2.
BF2, how it can be non-planar here? 3 atoms are there.
Yes, sir.
Vani, which one you missed?
Sir, SF.
SF4. Varun,
So that SO3, so
SO3. SO3 is trigonal planar, right? It is sp2, it is trigonal planar. Right, so we'll be keeping up to here only. In the next class, we'll be completing the dipole moment also, and we'll be starting the another topic also. Right? I think in this thing, at least you are comfortable, you are able to solve it. Next class, we'll be doing another topic. Like the dipole moment will be completing first.